just turned in homework number 9. Homework 10 will be due a week from today. I haven't yet loaded that onto Blackboard, but I'll do that this afternoon. So homework 10 is going to be due the same day as our second midterm exam. And I'll do the same thing that I did during the first midterm exam, which is to tell you the solution. Well, the answer, the final answer to those problems, just so you can know whether you're on track in advance of having the test. I'll tell you a little bit more details about the exam here in a minute, but then, of course, there's the ongoing reminder about the project. Today we're going to be talking about some topics that aren't directly addressed in the textbook, so there aren't related readings to price, demand, and break even, but I think they're important topics and useful nonetheless, and so there's supplemental materials online related to these topics, but I did want to point out there isn't a textbook chapter that goes along with it. So regarding the second midterm exam, it's a week from today. You'll have 50 minutes in class to take the test. And it's going to be similar in concept to the first, except for that maybe a little bit more of the points will come from problem solving than from conceptual problems. It'll have both. You should bring your laptop computer because there's going to be some questions where using Microsoft Excel, it'd probably be the only available way to do it in the time that's provided. So for example, it would be hard to do a external rate of return problem by hand, but it'd be pretty easy to do it by Excel. So when you do those Excel-based questions, the expectation and the requirement is that you start with just a blank file. So that means you're not allowed to access your previously solved homeworks. You shouldn't open up a previous example or in-class exercise file. You're starting with just a blank workbook. And of course, I'll be monitoring that during the exam to make sure that you comply with that expectation. But what you are allowed to bring to the test is a single page front and back of any kind of notes that you like. So you can have like a procedure summary that reminds you on how to do external rate of return. You could put the column titles that you should expect to have if you're doing an incremental rate of return. So just whatever kind of notes you want to make for yourself to do certain types of analysis, I'd encourage you to include that on the notes page that you prepare, because I'll provide the typical time value of money equations, meaning I'll provide the formulas that allows you to calculate find P given F, find A given P, those formulas, and I'll also give you any factor tables that I want you to use during the exam. But besides that, you should include any supplemental help or notes that you want on that page. Does anybody have questions related to the second midterm exam? Yeah.
Will there be a practice test online as well?
I don't know. It didn't get much use when I wrote that other one. I was able to see, well, maybe you used it, but most of your classmates didn't. So I'll have to get back to you on that. Yeah. Okay, other questions related to the second midterm exam? Yeah.
Which chapters are covered again?
Well, let's take a look at the schedule because that's the best way to see what's covered.
Homework 7 and up.
So the schedule that's posted on Blackboard, you can go to that at any time and see like which lectures go with what day. And so the emphasis on the exam is going to be material that was covered since the first midterm. Well, probably what you've already realized is that it all kind of naturally builds over time. So although I'm not going to have any questions probably that's just a strict find P given F, you're still going to have to apply that concept to solve some of these other techniques. So it's naturally cumulative, but if you're going to be focusing your time on what to study before the exam, probably lectures 16 through 29 are the ones that deserve the most attention. Just with the added asterisk that I didn't ask you a bonds question on the first test, and I really like asking bonds questions. So maybe you'll get it for the second midterm. Any final questions before we start talking about demand? Okay. Thanksgiving is only now just about a month away. And one of my favorite Thanksgiving traditions has nothing to do with family or turkeys. It's going to get the newspaper and figuring out what I'm going to shop on Black Friday, because I am a materialist. You know, I love to figure out which toaster oven I'm going to get, where's my favorite flat screen TV. It's kind of my focus on Thanksgiving is the newspaper and all the ads. And I'm not the only one, because if on Friday after Thanksgiving you drive around the mall or you drive around any kind of retail place, you'll find people lining up for the good deals. And so the lesson to draw from that is that you can stimulate demand by reducing prices. I think everybody here already knows that if you have high prices, demand for something is likely to go down. But if you've got low prices, demand is likely to go up. There are a handful of goods, though, that are insensitive or relatively insensitive to changes in price, like gasoline is one where it's relatively inelastic, where even if gas is $4 a gallon, you still need to get to work. So you're going to buy enough gasoline to get to work if it's $4 a gallon. If it became $10 a gallon, you might carpool, and then probably the demand for gas would go down. But there are certain things that are really sensitive to price, other things that are less sensitive to price. But the overall idea that we're going to be playing around with today is that there's a relationship between price and demand. Did anybody get in on the big promotion that Sheetz had on the 4th of July? I got a tank of premium for $1.77 per gallon. That's a pretty good price for premium, you know. But there were long lines. I went over to the gas station as soon as I heard about it. It was in the morning, probably around 9 o'clock. And I had to wait 25 minutes to fill up my tank. And when I drove by the Sheetz station later in the day, like 3 or 4, number one, I was amazed that they still had gas. I thought for sure they'd sell out. But they didn't. They must have had a fuel truck coming, but the lines were really, really long. I don't know how long people were waiting, but my guess would be more than an hour. So that's just another illustration of how price and demand is related. How much money do you think Sheetz made that day?
I don't know.
You think they made money that day?
No. It was not even $100 per barrel of oil at the time. A lot.
They lost tons of money. I mean, their usual markup is not $2, $3 a gallon per gas. They lost money. They were doing that, I think, just like to get attention or to break people out of their normal routines. Yeah, I think the typical markup I've heard for a gas station is that they're only making 10 or 15 cents a gallon for each gallon that they sell. That the raw materials, you know, the raw oil, which you've mentioned, the barrel price of oil is part of it, but then there's also the cost of refining the oil, transporting it to the station, and the overhead costs of having the station. So they lost money that day for sure.
Who's the loss leader to get people to buy their 4th of July beer there?
Buy their 4th of July beer? Yeah. I don't know if net overall, if they made or lost money that day, but it definitely got a lot of people going to Sheetz who ordinarily aren't shopping there. Amazon has been really successful over the years, and for a long time, almost 10 years, Amazon was losing money. People thought that if you were an Amazon shareholder, you're crazy. For the first decade of their existence, they were operating at a loss until finally they killed off a lot of competition, got enough volume that they became profitable. They found ways to generate revenue with getting people to sign up for Prime. Their Amazon Web Services, which is like cloud computing and web hosting, is very profitable, but their retail operation was just losing billions of dollars every quarter until finally they killed off competition like, for example, Toys R Us. If anybody's from the local area here, you may remember that there used to be a Toys R Us over by the Huntington Mall. They're not there anymore. I don't think there's anything in that right now. Is it a Halloween store? It used to be maybe like for about 6 months it was a trampoline park until COVID killed that off. But yeah, low prices will draw people to websites. And especially Amazon had a little bit of a head start because it was only recently that you started paying tax on Amazon purchases. I mean, for a long time, you could choose between buying a computer at Best Buy and paying 6% tax or buying it from Amazon and paying 0% tax. I mean, legally, you were supposed to report your purchases when you filed your annual income tax return, but I don't think most people remembered all of their online spending through the year when they filed their tax returns. So Amazon had a little bit of a competitive advantage over all their brick and mortar competition for a lot of years. So let's go over some definitions here. Price is an independent variable, meaning that it can be controlled by a manufacturer, the selling price. Now that's not to say that you can have the same direct control over your costs, but you can control your price that you're selling for. Now demand is dependent, which means it's the thing that's responding to price. And so there's a relationship between whether there's going to be more demand or less demand as the prices change. But you can't directly control demand. Like, we don't live in a Soviet economy where people have a gun to their head and are forced to buy certain products, except for health insurance. But I guess it's not a gun to your head. It's more of just you have to pay a fine if you don't buy that product. But aside from health insurance, you're not legally obligated to buy anything else. So you can only indirectly control demand for a product through the price. And so you could fill in the blanks here. If price increases, demand will decrease. If price decreases, demand will increase. So that's the rough lay of the land. Now, if we get a little bit more specific, we could graph the relationship between price and demand. Now, it's not always going to be linear like is suggested here. This is just the simplest case. It could be curved, but the bottom line is this is showing that if price goes down, price is on the vertical axis, then demand increases. And the slope of this line tells you how much of a reduction in price is going to stimulate how much of an increase in demand. So if we extended this curve over to the vertical, to the intercept with the vertical axis, so think of it, what's the physical significance of that intercept? It's saying that there's a certain price where there would be no demand. Or if you raised your price so high, even the die-hard collectors, even your best fanboy is no longer going to be purchasing the iPhone if it's $28,000 a phone. Maybe somebody still would. But if it was, there's a certain price at which nobody would buy an iPhone anymore. So that is what we're going to call variable A in a series of calculations that we do. And so just to go into detail about each of these, we're going to call price this variable P. Remember, that is the variable that we can control, and it's the revenue per unit. Revenue is different from profit. Revenue is just the money that you get without taking into account your expenses and costs. So the selling price isn't necessarily going to cover the cost, and we'll talk about the effect of that in a little bit. A, the intercept, where that curve goes up against the price vertical axis, that is the price where there would be no demand. B, the slope of that line is how much of a increase in demand there is for each decrease in price. And then finally, D is the number of units that are sold. And we use interchangeably demand with the sales figures. So we're going to say how much we sold is the same as how much the demand was. We're going to not distinguish between the two, but the reality is that there are certain rare items where there's more demand than the units sold, like certain collectible T-shirts or tennis shoes or something. Those are obscure, rare cases. For our purposes, we'll just say that demand and the number of units sold are interchangeable. Okay, so revenue is going to be the price of each item multiplied by the demand, or the number of units that are sold. So you can find your total revenue that you're making as a company by simply multiplying the purchasing price by how many items were sold. Remember that the purchasing price is itself able to be expressed in terms of demand. From this, P, we had an equation that expressed price in terms of the intercept, A, minus B, where B is the slope of the line, times D, where D is the demand. So this equation, we may not know directly. You'd need someone to do market research or hire an economist, but somebody out there could tell you, like, how steep is the curve? How many units of increased sales will you get if you decrease the price? And what is that price that no one will buy it at? So we could define this price equation and substitute it into the formula for revenue. So if we substitute, instead of just using P, if we substitute it in terms of D, then this is the equation that we could get for total revenue. So remember, A is the intercept, D is the number of units sold, and B is the slope of the price demand curve.
What's the T?
T means total revenue.
Oh, okay.
Yeah. So it's taking into account how many units are sold. So it's not the revenue per unit. It is the total revenue for your company in a certain period. So ordinarily, this would be expressed in terms of like per month or per year, how many units were sold. All right, so here is a really important figure. And if you're not in the habit of taking notes, this might be a good one to start on, because this figure is really important to understand. If we look on the horizontal axis, demand, remember that's the number of units that are being sold. So sketch this down. If you draw this curve, then maybe it'll help you keep it in your memory. There is an increase in revenue as you sell more items, but then something maybe a little bit counterintuitive starts happening. What this is saying, this is a generalized relationship. This is saying that if you continue to sell more and more units, actually your revenue is decreasing. So think about, how might that be possible? How is it that you're selling more units, but the amount of revenue your company is getting is decreasing?
You're saturating the market with your product.
Saturating your market, that's not a bad guess, but we're just assuming that those items are still being sold. So the demand is still high. So it's not like they're sitting on store shelves unpurchased. We're assuming they actually did get purchased, that there is a demand for the item, but for some reason your revenue is still going down.
Marketing costs.
What is it?
Marketing costs.
You said marketing costs. I think you're on the right track. It's not just marketing costs, but remember, how do we control demand? What's our one lever we can pull on?
The price gets very, very low.
The price, the way that we stimulated the demand was by reducing the price. And so what happens is you've lowered the price so much to get that high demand that actually your total revenue is decreasing, because although you're selling more units, you're selling them for lower and lower prices. And so there's some point at which the revenue is maximized, but then the revenue starts to decrease over time. Okay, so does everybody understand why the revenue peaks and then continues going down? It's because the only way that you can keep the demand high is by continuing to lower your price. And then if you lower it enough, you're not going to be making that much revenue, because remember, total revenue is the number of units sold multiplied by the purchase price. So if the number of units sold is high, but the purchase price is low, the product of those two may be lower at this high demand than it was at some optimal demand. Well, no, sorry, strike that. D hat is not optimal demand. It's maximum revenue. Those are actually two very different things. Maximum revenue is not necessarily optimal demand. Like optimal would mean what generates the most profits for you. But the interesting thing is that you're not necessarily going to make the most profits at maximum revenue. Anybody want to venture a guess why this point isn't not necessarily the most profitable?
Maximum cost as well.
Because we haven't talked about costs yet. Yeah, we don't, to know profit, we have to know revenue minus costs. And until we account for costs, we don't know where is it that the costs and the revenue are the furthest apart. Okay, so let's talk about cost. Cost of producing items includes fixed costs and variable costs. So fixed costs you could think of as maybe the equipment used to manufacture an item. So regardless of whether you're making 1,000 iPhone cases a day or 0 iPhone cases per day, you still have to pay rent to your landlord. You still have to pay for the equipment that you've purchased. Still have to pay taxes to the government for the land that you occupy. So there's all these costs that are unrelated to how many of the things you're making. But the variable costs are most often related to material expenses, labor expenses, and so those are the things that do depend on how much of the thing you're making. So fixed costs, as the name suggests, is fixed relative to demand. If you have low demand or high demand, the fixed costs don't change. But variable costs do increase your total costs if you are increasing the number of units sold. So this is showing some plastic pellets. A lot of things are made out of plastic these days. Plastic would be a variable cost. So would be the expense of the hourly labor that's there. But the warehouse that it's in, you're still paying rent on the warehouse regardless of whether you are running 3 shifts per day or 0 shifts per day. We can further break down the variable cost, C sub V, into the variable cost per unit multiplied by the demand. So if we wanted to know the overall for the whole month variable cost of plastic to make a cell phone case, then we'd multiply the number of units that were produced by the amount of cost that there is in a single unit for that raw material. So variable cost per unit is separate from the overall variable cost for a certain level of productivity. Now here's the important thing. Where we should be operating is that point that maximizes the profit. So what you want to maximize profit is high revenue and low costs. Now, to a certain extent, those two things are related because if you're not producing anything, if you have 0 cost, you're going to have 0 revenue. And generally, the more you make of something, you're able to capture economies of scale, where you can get a better deal buying a rail car full of flour, for example, than you can buying a bag of flour. So Heiner's Bakery here in Huntington, they probably spend less on their raw materials to make a loaf of bread than if you made a loaf of bread. So the more they make, some of their costs per unit are going down, but their total costs are going up. If they make 1 million loaves of bread in a month compared to 100,000 loaves of bread in a month, it may be that their operating cost per loaf decreases, but their overall operating costs are higher. So here's the sweet spot. D with a hat over it from the previous slide was maximum revenue, and D with a star is optimal demand. So optimal demand is the operating point that gives you the most profit. And so it is, if we're thinking about that graphical figure that had the curve of demand and price, remember A was the intercept with the vertical axis. A is the price that would have there to be no demand. V, this lowercase v, is the variable cost per unit divided by 2 times B, where B is the slope of the line, the slope of the cost demand curve. The break-even points are telling us how many do you have to sell to have covered your fixed costs and have like 0 profit. And then there's a certain point where if you've lowered the price so much to stimulate the demand, you'll actually have 0 profit as well. So there's 2 break-even points which define the range of profitable demand. So the lower point of the break-even points is where profitable demand begins, and then the upper of the break-even points tells you what is the maximum number of units that can be sold in order to achieve profitable operations. So as you'd expect, we're going to practice all of this today in the in-class exercise. And this is a tricky formula. There's a lot going on there. So you got to be really careful paying attention to details. My suggestion when you calculate the break-even points is don't try and do it all in your calculator all at once. You know, write down on the page some of the intermediate steps, show the equation, substitute in the variables, actually do a few of the intermediate calculations, and don't just do it in a single step because it's too easy to make a mistake and overlook something. So here's a graph where we have put an overlay of the total revenue curve. You've seen that total revenue curve before. That's nothing new, the total revenue. We've talked about that. But look at the cost curves. C sub t is the total cost. And so what are the two components of total cost? Well, it's the fixed cost, which is a flat line, because fixed costs do not vary based on the level of productivity, the level of units being sold. But the variable costs, C sub v, the variable costs go up depending on how many units are being made. So here's D star. Here's D star, and remember D hat was maximum revenue. Maximum revenue is not the same as maximum profit. So maximum profit, we just look at, we want to find out where is revenue above cost. Anytime revenue is above cost, it's profitable. So D prime 1 is the first point at which we're actually making profit. If we're to the left of that, like if you made less than D prime 1, the problem is you've got some revenue, but the revenue isn't enough to cover your costs. So you've got to make enough revenue so you've covered not only the fixed cost, but also the variable costs. So D prime 1 is we're saying finally our revenue is above the costs and we're in the range of profit. So if I move further to the right, I've got more profit. We want the revenue curve to be further away from the cost curve. Like, do you see how they're getting further away as I get further and further to the right? This is the point where they're as far away as they're going to get. And if I go to the left or to the right of this point, then the revenue curve is getting closer to the cost curve. So it's this D prime is where those two curves are as far away as they're going to get. So I see some nodding heads. One other thing to point out is the two curves are parallel to each other at that point. Look at the slope of the line is parallel to the cost curve at maximum profit. So that's actually what the formula is doing, is it's telling you what is the demand that sets the profit curve equal to the slope of the cost curve. Any questions about this figure? This is so important. This figure is really, really important. Okay, here is what we're going to do. We want to find out basically how much money can we make by selling this timing switch. What's the optimal sales that we should be aiming for? How much should we sell this thing for? To maximize our revenue. Not maximize our revenue, maximize our profits. Anything over here? Any extras? Okay, so we're going to solve the first part by hand, and then when we get to part E, I'll show you how to do that. But I think you could solve A, B, and C using the formulas that are provided there. What you're going to have to do, though, is the general form of the equation. Remember, if we go back to this figure, the general form of the equation is P equals A minus B times D. Okay, so in the problem statement, we've got P equals 180 minus 0.02 times D. All right, so I think you can see what is A, what is B, and with that, substitute it in here to find out optimal demand, maximum profit. So optimal demand is how many units you're going to be selling. Maximum profit, you'd multiply the number of units by the purchase price and subtract out the costs. So in the statement up here, it's saying the fixed costs are $73,000 a month and the variable cost is $83 per unit. So the C sub F, the fixed costs are $73,000 per month. And then the variable cost per unit, that is the C sub V. Well, we use the variable lowercase v is $83 per unit. Okay, so let me pause from talking, give you some time to think and calculate. And remember my suggestion that when it comes to calculating the break-even points, don't try to do it all at once in your calculator. Let it spread out on your page. So D has units associated with it. It's got a time component. And in this case, it's demand of units per month. So this equation that relates the amount of demand and the price, we're talking about units per month being sold. So the optimal volume would be 2425 units per month. And so then to find out the maximum profit, we're going to have to know what's the revenue at 2425 units per month and what is the cost at 2425 units per month. So the revenue part of it requires us to find out what's the purchasing price that would stimulate that amount of demand. So in order to achieve 2425 units per month of demand, what that means is we need to set the price at $131.50. So that's the price, multiply that by the number of units sold per month, and then we get the revenue per month is $318,887.50. So that's the first part of the profit. The second part of the profit is subtracting out the costs. And our costs per month are $73,000 for the fixed costs, and then the variable costs depend on how many units we're selling. And we know from the problem statement that the variable cost per unit is $83. So $83 times the 2425 that we're producing means that the overall cost per month is $274,275. So then the maximum profit will simply be the difference between the revenue and the costs. So the most we can make profits per month is $44,612.50 per month in our profits. So the range of profitable demand, we would use that break-even equation for the range of profitable demand. So if we go through that process, we'll find out that 932 units up to and including 39.18 is the range of profitable demand. And then if we just kind of sketched out conceptually some of the key points on a figure, we're going to have the first break-even point, which is where now the revenue is above the costs. We'll have the optimal demand, which is where the revenue curve is as far away from the cost curve as it's going to get. Then the second break-even point, beyond which we're actually losing money because our revenues are less than our costs. So we could just, let me show you real quick how we could illustrate this in Excel if we wanted to come up with maybe a little bit more scaled or accurate representation of things than this hand sketch. What we could have is the fixed cost per unit. Probably best if you just watch this one because I'm going to go through it quickly and you can come back to it later if you like. 73,000 is the fixed cost, and then we have the variable cost per unit is $83. The price for zero demand, variable A, is 180. And then the slope of the line, B, is 0.02. Okay, so demand, price, revenue, cost, and profit. So the demand, we just have to put in some guesses of how much demand we want to have. We, at the outset of a problem, may not know exactly how many units it's going to take to get through the entirety of the range of profitable demand. So it's a little bit iterative in that sense. Okay, the price, remember, is going to be 180 minus 0.02 times the demand. So this is going to just tell us what price would be related to what demand level. The revenue is simply demand times the price. The cost is going to be our fixed costs plus the number of units sold multiplied by the variable cost per unit. So I've got my costs going up over time, and profit is simply the revenue minus the costs. So what we can test is we can test to see, like when I calculated in the paper that the first break-even point was 932. So we go from negative at 900, now profitable at 1,000. So what about 932? We finally have some profit. But what about 931? It's negative. So 932 is our first break-even point, and then our second break-even point, according to the hand calculations, was 39.18. So let's try that. 39.18. It's positive, but 39.19 is negative. So we could graph. We don't have time for that now, but we could make a graph that puts on the same figure all of these things: the revenue curve, the cost curve, and the profit curve. So that's all the time we have for today. I'll see you in class on Wednesday.